Hi and welcome back to the course on cloud computing. Today we'll be covering disaster recovery and business continuity in the cloud. Now, in a regular business also, disaster recovery plays an important role in order to make sure that our business continues to run in case there is a natural disaster or any sort of mishap. So that's what we'll be talking about in this chapter. The key concepts that we'll be covering today would be business continuity. We'll be talking about call center as a service, disaster recovery as a service. Then we'll talk about disaster recovery plan. We'll cover hello, and then we'll talk mean time between the failure, redundant array, which is a RAID. And then we'll be talking about recovery point objective, RTO, which is recovery time objective, and service level agreement or service line agreements. And we have UPS, which is uninterrupted power supply, and finally how virus affects the overall business operations. Now the learning objectives that we'll be talking about in this chapter would be, we'll be describing about the business continuity, we'll describe the disaster recovery, we'll describe the benefits of cloud-based on or offsite backups, etc. We'll evaluate the risk of various threats and discuss the steps to mitigate them. We'll discuss the role of co-location as a business continuity and disaster recovery. We'll identify and discuss the variety of system threats. We'll talk about benefits of cloud-based phone systems, which is VoIP. We'll describe about the benefits of the cloud-based data storage, just like you use Dropbox or any other service through which you are storing things in the cloud. We'll describe the importance of testing, auditing, and business continuity and disaster recovery plans. And finally, we'll be talking about how can we create business continuity and disaster recovery plan. So let's try to understand what is business continuity and disaster recovery. For years, primary job of an IT staff or of an organization was to ensure the availability of the computing resources, application files, and even phone systems, not only on a day-to-day basis, but also in an event of the crisis or natural disaster. So, since we have a data center in our organization and we have a team of professionals, so they are usually responsible to make sure that things are working fine. If any of these things like application files or phone systems would stop working, it would affect the overall operations of the business. And whenever we are talking of a business, even a downtime of 1 to 2 minutes would cost a lot to a business who is totally operating online. If even the telephone systems are down, you'll not be able to reach the customers in order to respond to their queries, etc. Now, business continuity describes the policies, procedures, and actions taken by an organization to ensure the availability of critical business functions to employees, customers, and other key stakeholders. So you'll identify the key business areas which are there, which are really important for your business, and you want to make sure that in case there is a problem, a disaster, or any sort of natural calamities, your business should be up and running. Who must be responsible for that? What are the action items? What things you can do in order to make sure that things are up and running, and if you cannot make sure that things are immediately back online, what would be the downtime for that? Now, disaster recovery describes the steps in a business that will take to restore the operations in an event of a disaster like fire, flood, hurricane, tornado, etc. That how fast you can recover back to the previous position where were you. Now, following 9/11, business continuity and disaster recovery became a very real and essential IT function. The need of the business of the continuity was further strengthened during the COVID-19 pandemic, when companies had to shift their workforce from on-site to remote locations, etc., and still they were able to perform these operations. Now, lots of businesses shifted to online after pandemic, and they started using the systems or the technology in order to make sure that if anything goes down like that, still they'll be able to operate the businesses. Since now lots of companies are using the technology, most of the things are hosted in the cloud, there is a high demand to cover the business continuity and disaster recovery when we are talking about cloud computing. Now, a recovery point objective or the recovery and recovery time are two different things which are quite important when we talk about cloud computing. We have RPO, which we say at recovery point objective, and we have RTO, which is recovery time objective. The only difference in between is point and time. So a recovery point objective specifies the level to which data must be restored. Now, you'll have to decide that how frequently you are taking backup of a certain thing. If you are maintaining a backup of every hour or after every 2 hours or 6 hours on daily basis, so you'll calculate that if your business went down, what's the latest backup that you have in place which you can restore and continue your services from there. Suppose a server failed, and if you have a backup which is being maintained on hourly basis, as soon as a server breaks or it would stop working, you'll set up a new server and you restore the backup which is of the previous hour, so you lose the data of only 1 hour. That's recovery point objective. Then we have recovery time objective, specifies the maximum downtime that can occur before the company can resume the services. So you'll calculate the time that if a server failed, and the time that you would take in order to set up a server, restore everything, and to be back in business, that time would be calculated so that everyone is aware that in case if something goes down, how fast can you be online. Now, one of the first steps to develop the disaster recovery plan is to identify the assets, in which we include people, processes, and things, etc., that you want to protect, and the corresponding risk to each of these assets. The risk to an asset is the probability that an identified threat would occur and the impact of such occurrences. With the list in hand, you can now prioritize the steps you must perform to protect these assets. Often you cannot eliminate totally every risk. In such cases, you should seek to migrate or to minimize the risk or to mitigate it so that you have the minimum effect of it. For example, you cannot eliminate the hacker's ability to guess the system password. However, you can use strong password, you can mitigate the risk. In addition, there may be times when the risk has a low probability of occurring and the impact of the risk is low, that you simply accept the risk. Finally, these may be times when you cannot transfer the risk to someone else. For example, you may choose to insecure your building against fire or to obtain a malware insurance. Now, in the next one, we'll be talking about different threats that we have, and in threats, if we are talking about, is the drive failures, devices or the disk that we are using these days are the mechanical disk drives, and such they eventually wear out or would fail with the passage of time. Further, the threats such as the fire, flood, power surge, or any kind of threat can result in the loss of the disk-based data. Even newer non-mechanical solid-state disks can fail, and there is a high probability for them as well. So in order to calculate the mechanical failure devices that are associated with the mean time between the failure, we call them MTBF. Rating for a disk drive, that MTB may be 500,000 hours, or we can use round about 8 years. It is important that you understand that how manufacturers calculate the mean time between the failures. To start, the manufacturer may begin running 1000 disks, so they'll start them all together. When the first disk would fail, the manufacturer will note down the time. Let's say that after 500 hours the first disk would fail, so the manufacturer then multiplies the time by the number of the devices they tested and determine the mean time between failure. So it would be like they used it for 500 hours and they were using 1000 disks, so they are saying that approximate the mean time between the failure would be 500,000 hours. Now it's important to note that no device in the group can run near to 500,000 hours. It could be plus and minus in that time that they have predicted for that thing. Now, migrating the disk back or mitigating the disk failure is the first thing is to forecast the risk mitigation for the disk failure to have up-to-date disk backups. You must maintain the backup of the disk, making sure that if a disk fails, you must have a backup for that also. In addition to that, you must have a disk, physical disk available which can be replaced in case if this disk fails. If a disk fails, the company can simply replace the disk and restore the backup. But in some cases, the servers that you are using, if they are quite outdated, you must check if those disks are available with the local vendors or not. If they are not available, you must make sure that you must have all those disks which you are using in your data center must be stored somewhere safe in your premises, so that in case of a failure you don't have to wait for all the shipment and other things. That implies that the cause of the disk failure you'll have to identify, whether it is for fire, smoke, flood, or any other problem that damaged, or if the backup that you have is working or can be used or not. To reduce such risk, most companies store the disk backup at an off-site storage capacity. It could be online, it could be somewhere else in the country, it could be outside the city, but mostly they are maintaining a backup so that they can use it in case if there is a problem. Now we have RAID storage for that. The RAID is actually a redundant array of independent disks, with the help of which we maintain that the backup of the disk is maintained. Now many data centers use redundant array disk independently or inexpensively disk RAID to reduce the impact of the disk failure. RAID system contain multiple disk drives rather than a simple store the data on one drive. The RAID system stores the data across several drives, so that if your one disk fail out of the 3 or 4 disks which are used in a storage or in a server, the other disk would try to construct the data of the disk which is faulty. As soon as you'll replace the disk, the other disk would be combined together in order to build the data which was there on that disk which actually failed. The RAID system stores the data that can be used to reconstruct the file if one of the drives fails. In this way, if the disk fails, no file recovery is required from the tape backup, etc. The other disk would combine together to build the data of the disk which is failed. Instead, the IT member can simply replace the failed disk in the RAID system and would rebuild the disk contents on the fly. Now, RAID systems do not eliminate the need of the disk backup. If fire, flood, or theft occurs, the entire content of all the RAID drives may be lost. So, in case the tape backup of the drive becomes the data restoration solution, so it's better to maintain the backup on tapes, on the magnetic medium, maybe on the storage somewhere on the network, in the cloud, and maybe at a distant location which can be used. Now here we have different examples of RAID. For example, RAID level 0, RAID level 5, 1 and 10. So if we'll see RAID level 0, it is utilizing both disks. For example, if they are there, it requires at least 2 disks to configure, so the data would be written on both disks simultaneously or one after the another. Now if it is written one after the another, you need both disks to be working. If one disk would fail, in that case you lose the data because you don't have a backup of block number 1 in the drive number 2 as well, since we have block 1 here and block 2 over here. Whereas in RAID level 1 we call it a mirror RAID array as well. As you can see, the data on block number 1 is saved on the other drive, which is block number 1 of drive number 2. So if for example your disk drive 1 will fail, the disk drive 2 will have all the backup of the data which was stored on disk number 1. So we say that whenever a data is written on block number 1 of disk 1, it would be written on block number 1 of drive number 2 as well. So in that case, every drive is maintaining, or one drive is maintaining, the backup of the second drive as well. Whereas in RAID level 5 we have a data written on every block and then there is a parity. So block number 1A is over here, on the other one it would be block 2A, the third one would be block 3A and 4A, but every drive would keep a parity which would keep information of drive number 2, 3 or 4 consecutively, so that if drive number 3 would fail in this case, the other 3 drives would have this parity data which is maintaining the data of drive number 3, so it would combine together to rebuild the data which is lost once the hard drive is replaced. Then we have RAID number 10, which is a copy of RAID 1, which is mirroring. So there would be disks which are maintaining the backup of one another. Now we have cloud-based storage. Now in cloud-based storage not only lets users to access their data from any place at any time and often with any device, but it also provides enhanced data replication. So if we are storing our stuff in Google Cloud, or if we have Microsoft OneDrive or Google drive in order to save our data, or we are using Dropbox or any other application, it helps us in managing the data in the cloud. Now they provide you the surety that your data in the cloud would be 100% safe, and in case of a failure, it's their responsibility to make sure that their data is available in the cloud, because they are maintaining the backup of the data in the cloud, and then it would be self-replicated to another disk which would be outside the cloud. Maybe it would be outside the geographical location, so that if the data failure is there, or if any disk fails on the primary location, they'll be able to access the data from the secondary location. Many cloud-based data storage systems automatically replicate the cloud-based data at a second offsite cloud-based facility. In this way, if one of the RAID-based cloud devices fails, the cloud data which is provided or can be available immediately by the failover to the redundant device. Now, because of the cloud-based backups reside at a remote storage facility, the backups immediately reproduce or introduces a level of protection, because it is maintaining the data at two different locations, and it is checking the health of the data which is being saved at the other location as well. Because the backup files are immediately available from any device anywhere, the backup reduces the potential downtime, because no time is needed to find, retrieve, and restore the tape from the traditional backup storage facility. It would be automatically available. You won't even feel that something failed. Your traffic would be redirected to the secondary location where you will be able to download the data. Now there would be different kind of power failures as well, or we can call them disruption. Now computers are sensitive electronic devices. When a computer loses power, the user current unsaved data is lost. Now further, an electrical spike can permanently damage the computer electronic components, rendering the devices unusable, or it can destroy the disks as well. Although the power blackouts can be caused by the storms, accidents, or any terrorist attacks, etc., more common power brownouts is typically more damaging. Now, power brownouts can be quite common, especially in the hot summer months when electrical demand spikes ups and down. So any change in the voltage would affect the equipment which is there. We usually have voltage regulators which would provide a steady power source, so that if there is a spike, it would itself control the spike, so that the effect is not being transferred to the devices which are there. Now, to reduce the risk of an electrical surge damaging a computer or its peripherals, most users use or plug their computer to devices into a surge suppressor, which is a thing which calculates or which makes sure that a steady power source is provided to these devices. Although the surge suppressors can prevent the damaging power spikes for reaching the computer electronic equipment, the surge suppressors cannot protect against the power loss. Even they cannot protect themselves. If a more or a high spike would come to these devices, they would fail themselves as well, but they would protect the equipment which is there. Now, but they cannot protect against the power loss. They don't have the power source in order to provide power in case the main power or the raw power source is not there. So in that case, we use uninterruptible power source, which we call as UPS as well. If the power losses occurs, the user unsaved work will be lost. To reduce the risk, many users plug their devices into uninterrupted power sources. Most UPS devices provide 10 to 15 minutes of battery backup power, which gives users time to save their work and to shut down the systems. So it would maintain the backup in the batteries, and as soon as the power is disconnected, it would use its batteries to power up the devices. Now there is a mathematical calculation of it, that how much power is required by your data center, and if the UPS is powerful enough to power up those systems through 15, 20, 30, 45 minutes or an hour, that really depends on the storage capacity of power on your batteries. If the power outage lasts for long, the data center can switch to a large diesel power generators which can provide the power. Now here we have a power surge protector over here, which is a very small one instead of the one that we use in the data centers, and we have a surge suppressor over here which actually makes sure that the power remains steady on it, and through the storage in the battery of it, your devices would keep on running. Now that's a typical kind of a UPS that we use these days on the data centers. These are the battery packs of it in which we store the batteries, and this is the main module of it which is managing the batteries on these devices. Now with the help of the UPS, you'll be able to maintain that the devices are up and running, but it requires that from time to time you must be checking the health of these battery packs as well, that you'll switch off the main power source and you'll see that if the UPS is operating or not, and for how long they'll be able to manage the load that you have on your data center. This is a diesel power UPS. Usually we place it outside the building. It would have the power cables going all the way to the data center. So in case if there is a power failure which is taking more time than expected, you can use the diesel power generators, but they are a bit noisy, so usually they are placed outside the building so that at least your operations are continuously running. Now we have mitigation through co-location. Co-location is a process of replicating data processing, data storage, and possibly telecommunication equipment at a second remote facility. Now it could be a hot site, it could be a warm site, or it could be a cold site. We covered it earlier. Co-location is a thing in which you'll have everything which is ready to go in case if something fails, you'll be able to run your operations from the second facility. In other words, company will replicate its data center at a second facility. The advantage of co-location is that if one data center fails, the system can immediately fail to or can switch to the second facility. The disadvantage of co-location is its cost. Not only does the company will have to replicate its equipment, it must also pay for the power, air conditioning, staffing, and a second facility. So both locations would be up and running all the time. Co-location is one way to reduce the risk of the power failure. It is not enough to simply locate the second facility across the street, even across the town. One must place the second facility across the country or to eliminate this. For example, if there is an impact of storm attacks or any power grid failures, etc., the other location should be up and running. But when we are talking about the co-location, keep in mind that if we are using a cloud-based co-location, that's fairly easy for us to maintain, because once you'll sign up, for example, for Amazon Web Services, it would ask you for critical applications that you want to have the primary site as, for example, in Middle East, and the secondary site could be somewhere in Africa or America, etc., just to make sure that if there is a problem on the primary site, your operations would be up and running in case if the primary site fails. The second thing is, of course, the time which is required in order to access the services from the primary site. The time in order to access the services from the secondary source could be a bit slow as compared to the primary site. Now, about the computer viruses, users surf the web potentially downloading or installing the software and share the things like they save lots of stuff on the computers, their systems, and those on the network is a risk for the computer virus attack, for example spyware and ransomware, etc. Now it's estimated that within United States alone, it's lost its productivity time due to the computer viruses exceeding 100 billion per year. Now that's huge, just because of the viruses which usually being circulated on the network. Now the best defense against the computer viruses and spyware is to ensure that every system has an antivirus system installed. Most antivirus systems today automatically update themselves across the web and often daily with the most recent virus and spyware signatures. Now having an antivirus is not enough alone if the people are not paying attention to the proper guidelines in order to fight against the phishing emails and the viruses which are usually circulated through the network. Now antiviruses must be checked on a regular basis, that if they are getting all the latest definitions of the possible viruses out there in the market, because in case if the antivirus is not being updated on the computers and there is a new virus, you'll have almost no signature against signature details against the viruses which are recently released, since they are connected themselves to the automatic update server. So as soon as there is a new virus outbreak, it would automatically get the signatures or the protection against those viruses to protect your machines. Many organizations prevent users from installing their own softwares. Not only does this practice reduces the chances of the computer virus, in fact, it also aids the computers from preventing to installing any softwares, etc. People usually don't know what they are installing. Sometimes they are installing the pirated software or the softwares which are not downloaded from the actual known sources. So if those applications are installed on the computers, there are high chances that maybe they'll take the backup, or maybe they'll take the data from the computer and they'll update it or upload it to the servers online. Now, home users should enable firewall on the systems, either at their router or on the computer itself. Most companies place a firewall outside the network. In the organizations also, we have main firewall, and then we have the backups, and we have antivirus or the endpoint solutions installed, which protects our existence within the network. Companies must train the users to open the email attachments or not to open the email attachments. What are the procedures for that? How to identify that it is a clear email, or if it contains any attachment which would lead to any sort of phishing attacks, and the messages that they receive from the users that they don't know, so they must not be opening those emails. Now, that's a typical firewall, that there is an internet outside, and in between there is a hardware or a software which is a firewall which is protecting the users within the network. After that, we have the firewalls which we use on the network. You can see this is a Palo Alto firewall which is used on the network. Then we have some Cisco firewalls. Depending on the size of the network, you'll deploy it. And then we have Fortinet, which is another known firewall which is used on the network. You have the number of ports on which you can connect, and the traffic which comes from the outside internet first goes to these firewalls. You can even configure these firewalls through the web-based interface, and you can configure the policies, rules, what things to allow, and which websites to be blocked. All those different kind of things can be handled by the firewalls. Then we have fire protection systems. Fire can damage the computer resources and data stored in the disk and the local copies of the system backup. Thus, if the fire itself does not damage the equipment, the smoke or the other things which are putting out the fire would cause damage to the infrastructure. So we have different gadgets and devices which helps us in identifying, or which can detect smoke, which can detect the temperature and other things related to the overall safety of the equipment which is there on the network. Now, mitigating the risk of a fire, most offices have these sprinkler systems which destroys the computer when they deploy. Now, often there is no good way to protect office hardware other than simply to insure it. Now, in that way, if we are maintaining a backup which is not stored within the same building, if it's stored somewhere else and all the computers have a backup of the data, even if anything like that happens, you'll still be able to restore the data from the backup. The goal when such damage occurs is to get the users up and running again as soon as possible, when the goal is the business continuity. So if we have the backups and we can restore them, we can continue our operations as soon as possible. This means that the system backups must be up to date and must be stored on an off-site location, but the backups should be tested from time to time as well, just like the batteries of the UPS. It should be a workable backup. It's not like once you are actually trying to deploy the backup, or you are trying to restore the backup, it would give you a warning that it cannot restore the backup. Within a data center, you normally won't find sprinkler systems, but rather halon systems based on the compounds and carbon and one or more halogens, etc., that stop the fire by removing all the oxygen from the room. So as you know, oxygen is required to burn the fire, so it would suppress all the oxygen which is available in the room. Thus we'll be able to control the fire. Then we have a problem of floods, which leads to lots of issues on most of the places where it usually rains quite a lot. During the rainy season, the nightly news often leads with a story about a city or state that is underwater due to flooding, etc. Depending on the speed and the severity of the flood, companies may have a chance to remove the systems from the area before the flood hits. So if not the equipment and the data stored within it is typically lost. So you must be extra vigilant about the news, especially if it rains quite a lot in your area. Now we have different mitigating the risk floods. For example, we have this device which would detect any sort of water leakage in the area, and it would run an alarm, or if there is a pipe leakage or anything like that in the data center. Then we have another threat, which is just disgruntled employees. These are the employees who left the organization due to any reasons, or they were being fired. If in the past business protected themselves from the disgruntled employees by trying to limit the damage such as the employee could cause, they can install any sort of logic bombs or anything like that before leaving. That would have very negative consequences. As I previously discussed, company must ensure that up-to-date backups are in place. The company must use controls to limit the resources that employees can access to only those they need in order to perform their jobs. So one person should not have access to everything, where in case he's leaving with a bad mood, he'll be able to deploy something which would damage the stuff, which would delete the backups, or would format the machines once he's not around. Now, if an employee is terminated, the company must quickly disable the employee's access to all the systems. The companies often use badges, locked access, cameras, monitors, and facial recognition systems to limit the resources and the people who are allowed and not allowed into certain areas. Now in chapter number 5, we discussed about identification as a service. In the companies use a single sign-on process to authenticate you on different applications altogether. So in this way, if the company terminates an employee, the company can quickly disable the employee's access to all systems by simply disabling the employees within the authentication server. In virtualization chapter also, we examined desktop virtualization. If a company provides employees with a desktop on demand, most employees except for the one in charge of the desktop image can do little to harm the system itself. Now there is another problem of the equipment which is lost, and through that, if you are losing any potential information through that. Now each year within airports alone, thousands of the notebook computers are lost or stolen. When an employee loses a notebook, not only the company's or the computer is lost, but the user's local data, which may be confidential, will be lost as well. Today, with users carrying powerful handheld devices, the opportunity for loss becomes even greater. Given the amount of the information users store on each device, identify the theft often follows the theft of the device. Now sometimes these devices get missing, sometimes someone steals them from these airports or the common areas, etc. The main problem is that most of the time people don't report it, and the data which is stored on the computers is usually compromised. Information is the most important thing these days, so whoever takes access or whoever takes these devices, they actually try to recover all the data which is stored on the machines. Maybe they'll be able to get some financial details or the confidential data of the information which is stored on those devices. That is usually at risk if the equipment is lost. Now, if we are talking about how to mitigate the loss of the equipment, etc., to reduce the risk of the data loss when a device is lost, stolen, or broken, they must maintain a current backup of the device. Further, in some of the laptops and handheld devices, if they are issued by the company itself, there are built-in chips on the devices which would help them locate the devices even if they went missing. To reduce access to the company's sensitive data, many systems require a username and password, maybe biometrics or encryption algorithms, so that if the hacker would gain access to the system, they'll not be able to gain access to the data. Although such techniques can be bypassed by advanced hackers, they will prevent the most criminals from accessing the data. So if it's not a hacker, if it's a newbie and somehow they gained access to the system, they won't be able to open it easily and see what is stored on those systems. Typically, the more company utilizes the cloud, the less risk of the company will have with respect to the loss of device. If, for example, a user stores or synchronizes the key files in the cloud-based data repository instead of saving it on the computer, even if the device is lost, the data loss would be minimum. But the problem for that is that if everything is stored in the cloud, and if, for example, you are in the airplane or you're traveling somewhere where you don't have access to the internet, you won't be able to access the data which is stored in the cloud. Likewise, if company uses a cloud-based data such as Exchange Online, the user will, or without the email, calendar, or the contactless information will not be available for a brief period of time. Now for the desktop failure, desktop computers like all other devices may eventually wear out or would fail or would stop working as well. Now the cause could be a failure, maybe a bad disk, motherboard is not working, power failure, or any kind of hardware problem could be there. The bottom line is the data that the user is now without a system, so he cannot perform his operations, and the everything whatever was there was saved on the computer itself. Now how can we mitigate it? The first step is to recovering from the desktop failure is to ensure that the current backup and the user files and everything is stored on that and it can be recovered. Many companies uses the store key files on a network disk, which the companies can easily back up and restore it later. In most companies, a user experienced desktop failure will be offline until the IT staff can locate the replacement of the computer, install and configure the software, restore the backup and any user local files, and then make the system available. Most of the companies are maintaining the backup. They call it by a technique. They create the backup of the systems is the imaging, that they have created an image of a system with all the softwares and applications installed on it. So in case if a system fails, they'll just deploy the image, configure it, rename it, and assign an IP address and other things, and then they'll restore the data so that it is back up and running. A few hours of the employee downtime can have a significant loss on the financial cycle of the organization. Now, cloud-based mitigation of the failed drive devices. In chapter number 8, virtualization, we examine desktop virtualization. If a company delivers the user desktop on demand, a user whose systems has failed need only stand up, walk to another system and log in. The employee can then resume the work right here where she left off. Further, the user stores the files in the cloud, or he or she can access the files from any device or the software, for example Office 365. So if the computer is used just for the basic usage and rest of the data is stored in the cloud, so regardless of the computer, if it fails, the user will be able to log in by his username or password and will be able to find all the data which is stored in the Microsoft cloud. Now, just like the PC failures, we have server failures as well. Because most of the servers today are blade servers, replacing the server is a relatively simple process as long as the company has extra servers available. In some cases, they don't have the server available. So again, the backup is important. Or if you are utilizing the cloud-based services like infrastructure as a service, you won't be able to have problem of the server failures or the backup of the data which is constantly backed up in the cloud. Because most servers boot from the network attached storage, or the storage which is there on your network, the process of getting the new server up and running should be easy and can be managed. As you can see, these are the blade servers which are installed on the network. This is just the example of one of the rack servers which are used on the network, and you can see an IP address on it. Like with the help of the IP address, you can reach the server and can manage it from there. Now, how can we mitigate the server failures in the cloud? Given that not only the cost factors but also the advantages discussed throughout the chapter, where we were talking about platform as a service and infrastructure as a service was there, such the providers typically 99.9% uptime through the hardware and the redundancy with automatic failover, that in case if something fails, they'll be able to restore the data as soon as possible. Just like computer, network and other things, just like computer and servers, we could have a network failure as well. Although network consists of primarily of the cables and simple switching devices, etc., that can have an issue as well. For simple networks, the network will remain down until the faulty device or cable is identified, or it could be replaced. Now, just like the UPS is required in order to power up the data center, most of the time the small switch cabinets which are available in different part of the building as well, where you have switches, etc., there are small UPS connected to those switches as well. Because in case if there is a power failure in a segment of a building, if your switches are up and running and rest of the devices like the Wi-Fi access points, etc., are available and are connected to the same switches, they'll be up. You'll be able to run even the surveillance cameras through that, and the people would be able to access or run their services through the laptops or the mobile phone rather than relying on the main power source, which would power up their computers in the network. So if we want to mitigate the risk which is associated with the network for home computer users, when a network fails, users are going to be offline until a fix is applied. The problem resides within the internet service provider. The user can do nothing to resolve that issue because the internet is provided by the network service provider or the internet service provider. You can only switch to 4G or 5G wireless networks or the hotspot devices as a backup method in order to run your services. That's why there are redundant internet power supplies also available on the premises, that in case if you lose access to your main primary access to the internet, you must have a secondary source with the help of which you can have your systems up and running. To avoid the network from becoming a potential single point of failure, which we call it SPF also, some companies bring a second internet source from a vendor other than their primary internet service provider. In this way, if one network provider fails, the company can gain access to the internet through the backup power source or the backup network source. But in this case, if you are signing up with a company for a year plan, and if one or two times only your internet would go down, paying for a secondary source sometimes is a bit too much. So they must have some technologies or the resources like 4G or 5G connections which should be powerful enough to provide the internet to everyone in the organization. Further, given with the backup time in this place, many companies will use its load balancing with their bandwidth and demands, etc. So they'll power up the systems which are critical systems, and they'll provide internet access to those systems which would require an external access, and your external customer shall not be affected by that. Now, cloud-based mitigation of network failure is at a first consideration relying on the cloud applications and data storage may take the thought of a network failure quite concerning. Many companies provide redundant network connections to the internet to reduce the risk, uptime, and to make sure that it is mostly up, and same is true for the cloud service provider. Again, it would guarantee the uptime as 99.99. Again, just like other things, we have database failures also. Most companies today rely on the database management systems to store wide range of data for the customers, human resource data, application data, even the website which you are running. Most of the websites are database driven, so whatever appears on the screen is usually saved in the database. So it is really important to keep trace or to have a backup of the data which is stored in the database, either in the same cloud or to a remote location. So if a company database fails, many applications will fail as well. Now, the mitigation measures for the database failure is that the first database is reducing the risk of the database failure is to maintain the current backup of the database. You can even have it on premises so that if the database fails, which is there in the cloud, at least you'll use the database instance which is available on premises to access the data which was saved in the cloud. If the database fails, IT staff can restore the backup. Unfortunately, the database and the applications that rely on it will be down while the restoration process will continue. Now, to reduce the risk of the database downtown as a result of the database failures, company typically replicate data across the two database systems in the real time. Even in a typical business environment, if you have a data center on premises, usually there is a replication of the data taking place. When an operation updates the data within the database replication software will immediately update both databases just to make sure that your information is up to date and available. Now, as you just learned, many companies replicate the database controls in real time to reduce the potential downtime. The advantages of the database replication is it requires two servers at the primary location and a co-location, and may be complicated for the developers to initially configure that from where you'll be reading the data exactly. Most cloud-based database storage providers use a transparent database replication. So if a database cloud in one cloud fails, it would be running, or they'll switch it over immediately to the backup source. Now further, because the replication can occur in both directions, the system can use the second database for the load balancing. If the database is updated, either the system will change and would replicate from the secondary to primary rather than from the primary to secondary. Many cloud service providers offer database services, which we call as DBaaS, which is database as a service, which will provide not only the administration of the cloud-based database in the cloud, but also the backup and the replication, etc. As you can see in the cloud, there is a cloud in which you have a server and a database which is replicated somewhere in the cloud again, where you have a replication of the server and the database. So in case if one of the location fails, you still be able to access the data in the cloud. Now, we cannot ignore the importance of phone systems, since nowadays we are using voice over internet protocols. Most of our telephone exchanges are also IP based, so we must be concerned about the telephone systems if they are working or not. Despite the fact that virtually all employees carry a cell phone today, most organizations still maintain phone systems that provide voicemail, conferencing, calling, and call forwarding, etc. Since they are making lots of calls within the building itself, it is really easy to have an exchange on premises, so that at least your local calls would be free. All the calls that you'll be making outside the network, you'll be charged for that. And in case if the main telephone line is down by the telephone company or your telecom operator, you'll still be able to make calls within the organization or within the building. If the phone system fails, the company can restore, or the only resort is your cell phones. Unfortunately, customers calling into company would not know which number to call, because now your exchange is down, no calls are being forwarded to you. But in some cases, most of the organizations have the latest ways in order to communicate with their customers through WhatsApp or any other social media platform. So if the telephones are down, still they'll be able to access or can reach the company for support or anything which they are looking for. Now, how to mitigate the phone system's failures? Historically, there have been few ways outside the redundancy to reduce the impact of the phone system failures. That was the case until the advent of cloud-based phone systems known as call centers as a service, which is a cloud-based solution to avoid a single point of failure of the phone systems. Cloud-based phone systems have now emerged. The cloud-based systems provide the functionality of the traditional phone systems. Behind the scenes provide the replication. So if you have a cloud-based system, for example, if you are using voice over internet protocol, VoIP, and you have the telephone exchanges which are linked to the internet as well, even if you're traveling somewhere and if you are having a IP based phone, regardless whether you are in the country or not, all calls that you are making using those IP phones will be considered as a local call, since you are using or connected to the main server of your exchange which is hosted in your home country. Now, revisiting the service level agreements. When you sign a service level agreement to a cloud-based solution provider, your agreement will normally contain the clauses which we call SLAs. The SLA defines the level of the service that the cloud-based company would provide you. It would have all the legal formalities. The components of a service line agreement will include mean time between failures, uptime percentage, throughput, and after the performance benchmarks. Also, even the security and other parameters are discussed in it as well, that if there are any security complications, who are responsible for those things. And before you enter into an agreement, pay a close attention to the details of SLA. Now, there could be different ways to assess the risk. For example, we can list the risks that we have, and then we can decide the occurrence or the probability of it and how it would impact your business in a longer way. For example, a disk failure, the probability of happening is low, but how it would affect your business, that is quite high, so you'll have to pay special attention on that. On the other side, if you have phone system failure, the occurrence probability is low, but the business continuity impact is medium. And if a server power failure is there, if power failure happens, it means your entire infrastructure would be down. So the probability of occurrence is high, and even the business impact would be high as well. So that brings us to the end of the chapter. We covered the business continuity plan. We covered about the disaster recovery. We talked about all the devices and the mean time between the failures, etc. Then we talked about the RAID levels. What is the difference in cloud-based backup? Why do we need the UPS, and how the viruses affects the system? Even the ransomware is very important to consider over over here, which would encrypt the computers and will not be able to access the things stored on the computers. Then computer viruses shall be protected against the antiviruses that we have installed. It could be any natural disaster through which you will not be able to access the systems. This guaranteed employees can play an important role in jeopardizing the entire infrastructure. To reduce the risk on a single point of failure, must the businesses have a co-location, etc. Businesses today are dependent on the access on the internet, so there should be a backup source for that. A disaster recovery plan should be there, which would highlight all the key weaknesses of the system and how can you overcome them in case there is a problem. And then we talked about recovery point failure and recovery time objectives. So that was about disaster recovery and business continuity in the cloud. That's it for today. Thank you very much.